All right, good morning, everyone. Welcome to Elevator World's webinar. We will be starting very soon. It's 9:01 Central, 10:01 Eastern. Got a number of people joining, and so we're just gonna give it just a few more minutes to let as many folks as possible join the webinar, and then we'll get started. Looking good, looking good. Folks are joining. All right. We've got a good number of folks here, so I think we can go ahead and get started. So welcome everybody. Welcome to Elevator World's an Elevator World industry webinar. I'm T. Bruce McKinnon. I'm the president of Elevator World, and I'll be the moderator for today's webinar. Today's webinar is presented by Encoder Products Company, EPC, a leading designer and worldwide manufacturer of motion sensing devices. EPC is one of the largest privately held encoder manufacturers in North America, producing the most complete line of rotary encoders in the industry. The topic for today's webinar is how to control motion, door speed, acceleration, and tension using an encoder. Encoders play a pivotal role in the experience passengers have in an elevator. These devices constantly monitor the elevator's position and speed, ensuring a smooth transition between floors. By providing real-time feedback to the control system, encoders enhance safety, efficiency, and passenger comfort. Whether it is detecting irregularities in movement or accurately stopping at designated floors, encoders are precision components that can guarantee a reliable and seamless elevator ride. Today, our speakers from Encoder Products Company are Sarah Walters and Jared Stearns. Sarah is the business development engineer and technical applications manager at EPC. She has an MS in electrical engineering from the University of Colorado, Boulder, and a BS in electrical engineering from the University of Portland. Jared is the sales manager for EPC, covering the Northeast, Southeast, and Midwest markets. Jared has an MS in technology management from Central Connecticut State University and was also a sergeant in the U.S. Marines. Hoorah! We also have Scott Brown from Elevator World, who will be monitoring the chat and question and answer section during the presentation. The presentation will last roughly 20-25 minutes. We encourage you to post your questions in the Q&A section or the chat section. And at the end of the presentation, we will answer as many questions as possible. So with that, Jared and Sarah, the screen is yours. Jared, you're muted.
Oh, you always do it at the beginning of these things, don't you, T. Bruce? That happen every time you do one?
Pretty much.
I'll blame it on not being good at Zoom. We may see that again. So thanks for the introduction, T. Bruce. Again, I'm Jared Stearns. We have Sarah Walter below. Today, we're going to talk about how to use encoders for motion feedback in various applications within elevators. Go to next slide here. Sarah Walter is up first. If you want to introduce yourself, Sarah.
Yes, hi. As T. Bruce mentioned, I'm the business development engineer and technical applications manager, and my background is in electrical engineering.
All right, and I'm Jared. I'm the sales manager for basically everything east of the Mississippi River for Encoder Products Company. And my background is been in encoders for about 25 years now. Started off in machine tools, working a lot with CNCs and injection mold, running a team of technicians, rebuilding and maintaining equipment around the country, and then eventually jumped ship to a manufacturer, working with Encoder Products now on the sales side instead of in the field. Encoder Products is a really cool company. We're based in northern Idaho. If you look at Idaho on a map and kind of draw it out, we're right at the top of what we call, or what they call, I'm from Connecticut, but what people in Idaho call the smokestack. And it's in a pretty remote area. We're an American manufacturer, about 170 employees. And in 1969, the company was founded. And because we're so remote, we've had to do a lot ourselves over the years. And that's made us a really special company. We're not just an assembler of parts that we import from overseas. We're a true manufacturer. We machine our hubs. We machine our shafts. We print many of our optical discs in-house. We populate our PCBs, the electrical boards, in-house. So we really have tight control over our quality and the ability to customize that we're going to get into in this presentation. So what are we going to discuss in this webinar today? Well, first and foremost, what is an encoder? In the elevator industry, there's a lot of sensors that you see every day, and we're just one of those sensors. What's unique? What is our function? What do we do as encoders? How and where are these encoders used in an elevator system? So we'll go over what they are in general, and then we're going to talk about, well, how does that sensor get utilized within elevators? The next thing we're going to talk about is EPC is unique, being America-based, is how do you find a replacement encoder that you may need? You know, if you're an elevator contractor and you're repairing or modernizing an elevator and you run into an encoder that you can't find. There's all flavors, all sizes out there. Many encoders used in the elevator industry have gone into life, and you're struggling to get a replacement. We're going to go over how we can help you do that. And then we can also custom engineer new solutions for you as well. So those are the four main topics. Sarah will take over the first for what is an encoder anyway.
All right. Thanks, Jared. All right, go ahead and bring up the next slide. All right, we'll start with the basic principles of operation. Today, we're mostly focusing on rotary style encoders. So what's shown here is the components that are built upon a rotating shaft. So that's then connected to the mechanical apparatus within the application. So there's generally two different types of sensors used, optical or magnetic. So the optical kind of shown on the far right-hand side there, you have a light source or LED, and then a code disc that's rotating on the shaft, and then a photodetector that's picking up the light, and as it transmits through the disc, and then the electronics that then output the signal that would then go to the controller. For the magnetic, which is shown on the left-hand side there, we're talking about a magnetic target. In this case, it's a magnetic disc, which has a combination of north and south poles around that shaft, and then a magnetic sensor that would then pick up the changes as that rotates. And then we'll talk about the two different styles of output based on this type of, whether it's optical or magnetic type of sensing. So if you go on to the next slide there, Jared. We'll start with incremental. So incremental is probably the most common encoder that you'll see out in the world. So incremental, it's a very straightforward, essentially a pulse train that you'll see as the shaft rotates. So the code disc is basically just a series of tick marks, and as it rotates, you either see light or you don't in the case of optical. In the case of magnetic, it's obviously those north and south poles. So the output from the incremental is in most cases, especially with EPC products, it's a digital square wave. It's either on or off. The benefits of incremental encoders are that they're very cost effective since they are a more simple design. They're great for high frequency response, simple setup and interface, like I mentioned with the controls, that digital square wave on or off. And they're very reliable as they've been in operation for decades. Drawbacks, so loss of counts or position. Since incremental doesn't provide any information about where it is in that 360-degree revolution, oftentimes you'll have to do a mechanical zero to reestablish your home. So obviously another drawback is once you power on, that position is unknown in the 360. And there is possibility for error accumulation through that communication line or control system potentially. So that's incrementals in a brief overview. The other style is the absolute type encoder. And on the right-hand side, you'll see an example of an incremental disk compared with an absolute disk in the case of an optical absolute. So the absolute disk actually has unique tracks that represent a binary position. So anywhere you are in that 360, it actually reads that unique position value. So the benefits then for absolutes, you know the exact position of the object. Even after power loss, once you turn power back on, you can read that position value and know where you are. So providing shaft position, it also provides speed and also direction of turn and the number of resolutions. So there's multi-turn encoders that also have the capability to keep track of how many times you've turned around and in which direction. They can integrate with various communication protocols. So that position value can be reported via a bus protocol like CAN bus, Profibus, SSI, or via Ethernet protocols like EtherCAT or Profinet. So that's kind of the various flavors of protocols that you could encounter. The drawbacks, because of those extra features, that is typically an added cost. The complexity is a little bit more than those simpler incrementals, so it can be a higher level of maintenance as well. And then we'll get into now where encoders are used in the elevator system, and I'll let Jared take it from there.
Thanks, Sarah. It was great 101 there. As just a sales person in the field, I like to simplify it to incremental encoders go tick, 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 and you count the ticks. And an absolute encoder, it's like reading your watch face. It tells you what position it is. You can look away from your watch. You can look back at it in 5 minutes and still know what time it is. You didn't have to count the ticks to get there. So how would you use that? Well, what do you want an encoder for? I apologize, my talking heads here are right in the way of my bullet points. There we go. So how would you use an elevator, an encoder with elevators? What are you expecting them to do? Well, you're going to use an encoder for precise position and control, definitely critical in the elevator industry. You'd use it for constant speed monitoring of the movement of a car. You use it to ensure the smooth ride of a car. You need an encoder for safety. So you're using it to position it, and you need it to position in a safe way. Real-time feedback, efficiency, and performance. You use an encoder on an induction motor, and you run it closed loop. You're going to be running that whole system more efficiently than if you were running the system open loop. So first example here is main motor control. So we have a motor roomless design here, MRL, I believe. And in this design, you have a large drive motor that is lifting and lowering this car through moving the ropes. And the encoder is attached to that motor. So the encoder is built into this motor, and it's rotating with the shaft of the motor. Now, even though it's not a linear tape system that's installed, say, in the wall with the car, because you can use arithmetic to equate rotation of this encoder to the amount of rope being taken in or out. You can use that encoder for positioning the car. You can use it for knowing how fast the car is moving. You can read the encoder output, incremental or absolute, and know the direction that the car is moving. So all of those can be done with a rotary encoder, an encoder that spins. Total system monitoring, we can know if the car is moving and we didn't want it to, if there's uncontrolled motion that pushes it. And floor leveling control. We're across a wide variety of industries. Yesterday, I was talking to a company that builds corn choppers. I'm no expert in elevators, but we do a lot with elevators, and one of it is with residential elevators. So my understanding is a lot of residential elevators use proximity switches to do the floor levels. Very low-cost rudimentary design for residential. And the trouble I'm told with that is that when you use the proximity switches, you have a very jarring motion when you hit each floor. You hit the switch and you stop. So we're doing systems now to put rotary encoders with a draw wire assembly to give a position, a constant position of that elevator car in residential elevators. And that'll allow for better floor leveling. The encoder is going to tell the control when it's 2 or 3 or 6 inches away from the floor to start a nice deceleration ramp and have a nice smooth stop and a smooth start. So encoders are used for that. Door motor control. So determine the exact opening and closing position of the doors on a car. Very often there's a small fractional horsepower motor that I've seen installed on the top of the car with some mechanics to open and close the doors. The ones I've seen in the past have proximity switches. You know if the door is open and you know if the door is closed, but you're not controlling how fast that door opens or closes with those switches. You just know if they're opened or closed. And now you'll see designs where an encoder is installed on the motor, on that door operator, for regulating the speed. And that's going to become something I'm told that we will see more and more of, whether it be ADA regulations or other code that requires you do not exceed a certain speed when the door closes specifically. You use an encoder on that motor to regulate that speed and ensure you're not going too fast. The governor system. So the governor system on an elevator can also include an encoder. This very often can be redundant to an encoder that's on main motor. This governor system is used for very similar things. Over travel detection. It's moving when it shouldn't move. It can also be used to compare to the main motor that we're seeing motion, equal motion on both sides. So basically it's a redundant check on the whole speed of the system. So common encoders used in an elevator industry. Sarah's going to go over these, and these are Encoder products models that you will see. Not only will you see models like this, but you're going to see a lot of other competitors' products that look very similar to this. So Sarah, take it away.
All right, thanks, Jared. Depending on the application, most of the time we're going to be looking at the mechanical integration to determine what model that we'll use. In this case, for the main motor, we're generally talking about a large motor. So we'll want to look at a larger sized encoder. So in these two, the model 25T/H and the model 25SF, those are our 2.5-inch encoders. One is a through or hollow bore that's meant to mount directly onto a shaft, whereas the 25S is a shafted unit so that it can be coupled with an existing shaft. Both of them are built with larger bearings, obviously to handle more of an industrial or heavy-duty application, such as working with that main motor. The 25T is probably the most straightforward, as you can actually mount it directly to that auxiliary shaft on the motor. And this particular model has swappable bore sizes so that you can swap out depending on which motor you're integrating it with, as well as those flex mounts that you can kind of see there in the photo, and finding a bolt hole that works. Depending on the size of the motors, those can vary in size. Then I think the other one Jared mentioned was the door motor positioning. So these are obviously in a more compact space on a smaller motor. So we're looking at a little bit smaller design. So these are the 1.5-inch, the model 15T/H, which not only is smaller in diameter, but also that height of the overall encoder is roughly around an inch, a little over an inch, so it can fit into a tight space on the back of that small motor, but also has the same, precision of the optical feedback. And as with the 260, it's actually just slightly larger. It's a 2-inch, but again, it's a more compact design. Both these models have commutation options for for motors that use pole pairs to drive the windings as well. And then the other system that we mentioned was the governor system. Again, typically that's a mechanical integration that requires a slightly larger encoder. So in this case, we're talking about a 58 millimeter diameter encoder, highly configurable. This one we actually can factory program from a CPR of 1 to 65,536, a bit higher than most elevator applications will use, but it is nice to have that flexibility, especially for drop-in replacements.
All right, thank you, Sarah.
Yeah, Jared, go take it away. You're gonna go over the replacement encoder as I just mentioned.
I am. And actually, I'm going to keep it on the slide one more second because it's going to be
Sure.
important for that. You'll see in this model, the resolution is 1 to 65,536. And we just had a package of 5 modernizations we did where the resolution required was 16,384 per resolution, per revolution. So that resolution can get high even with elevators. And when it comes to replacement encoders, it's very good to know that Encoder Products has programmable encoders. We have a variety of elevator contractors who actually keep that programmable on the shelf because it is so versatile, fit many different repairs. So in your industry, you have mechanics out in the field. They go to a down elevator, they evaluate what's wrong, and they see they have a bad encoder. What do? Well, there is just a tremendous, probably more than, and like I said, my background, a lot in agriculture, a lot in mobile equipment, and a lot in automation. And elevators have a wide variety of encoders that have been installed over the decades. So different wiring, different shapes, different packages. And there is a good number of those companies that no longer exist, or they've end-of-lifed the existing products that you find. So you could be stuck where you need a replacement encoder and you cannot get that same encoder anymore. What do? Well, Encoder Products offers a service where all you do is you take a picture of the label. Most encoder part numbers are very long, can be over 30 digits sometimes. Don't bother trying to write down the part number. There's often other useful clues on encoder product labels, such as input voltages and output types that we can use in addition to the part numbers to cross them. So take a picture of that label. Or if the label's hard to read, find a sister unit in the same building, find a print or a schematic if that's available, and send it to us. We have 2 full-time employees at the factory. That's all they do is go through data sheets and prints and come up with what we can offer either for a drop-in replacement or for as close as we can get. If we can get close, let's say it's just a matter of the A and B channels need to be swapped to match something like this, or hey, the A is a yellow wire instead of a purple wire. You're going to have to change that, use this color wire instead of that. We put those notes in the information when we return that cross. And we have a goal at Encoder Products that you will get that information within 24 hours of taking that picture. The factory is 3 hours behind. If you're on the East Coast, you got a 3-hour advantage. We actually try to get you that cross in the same day. Most of the crosses are done in a few hours and sent back. We've been crossing encoders for decades, so there's a good chance we've crossed it before, and we have a library of doing that. So take a picture, send it in, get a cup of coffee, and we'll get you pretty quick back a replacement solution from Encoder Products. What happens, though, if you send us something that requires a mount that's not on our website, that's not in our data sheets, a connector style that you don't see in the data sheets, a resolution we haven't seen before? That's where custom applications come in. So if we don't have that drop-in replacement cross and you don't have a drop-in solution available to you from the OEM, the original OEM, we do a lot of custom replacements. We call them specs, custom designs. And we have over 1,000 unpublished specs, many of them for the elevator industry, and unpublished options, either getting pinouts you need, wiring connectors. And because we are a small company that is, like I said, vertically integrated, we make our own parts in-house. It's actually very modest engineering cost-wise to have us make you a custom solution. This 16,384 encoder had a terminal block instead of a connector on it. Had a custom mount and had that resolution 16384 that we had to do with the programmable, and that was just for 5 pieces. And the engineering fee was a non-issue to get 5 pieces and get those elevator running. It is not just a service for the big OEMs to get custom parts made. We have a real life application here. Somebody needed redundant feedback. they needed 2 incremental outputs, so 2 encoders that go tick, 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 and they needed to fit in a small space. So we took our Model 15 1.5" encoder here. We took the plastic cover off. We machined a metal cover and recessed a fit to take our magnetic incremental that you see here, our Model 30M, and we installed this Model 30M on top of our 15T and made a redundant output encoder that was a little over 1.5 inches tall to fit inside of a small space inside of an elevator. So that's a real life example. I believe it was 8 weeks, custom machine parts and everything to turn that around with drawings and prints. Many of the custom designs we do for elevators involve redundancy, just like this one on the screen. That is definitely becoming more and more common in the elevator industry and in the world in general, whether it be mobile equipment, cranes, forklifts, in all manufacturing. Safety standards are requiring more and more encoders to require dual feedback. That way, if they're always putting out the same, if one side fails, you have a safely controlled fault. So if you see more of that, another great place that we fit is providing you redundant feedback, customized to your need and customized to your physical and electrical requirements. That's all. We have additional resources here, a whole bunch of QR codes to throw at you. The first 2 is some brochures on our elevator specific products and also on custom engineering. And then this next page has all of our contact information. This here QR code is for cross references. You want to take a picture of that one now, just keep it in your photos on your iPhone or your Android. And then the next time you need that cross reference, just fill it out. You can go right there, take a picture, hit submit. We'll get back to you in 24 hours. This is our YouTube page if you really want to hear my voice anymore. And email for sales, and then our contact us. This is a form you'd fill out, and this is emailing us directly. T. Bruce, I'm assuming this presentation is available to everybody afterwards for these QR codes?
Yeah, absolutely. The whole presentation will be emailed to everyone that attended as well as signed up and couldn't attend. So they'll get this information for sure. Also, you can certainly reach out directly to Jared or Sarah. Jared S at encoder.com, Sarah W at encoder.com. We do have a few questions that we have here. I have a few questions, and there's a few questions that have been sent in. I'm curious, how long has MPC really been focused on the elevator sector? You guys been serving them for a while, or is this fairly new, or what?
I'll take that one, Sarah. So you're muted, I'm sorry. I've been with the company since 2017, and long before I was there, the company has been working with American elevator equipment manufacturers for a long time, providing custom solutions, many of those solutions having unique feedback for safety. And some of that unique feedback is very unique just to those OEMs, not something that became industry standard. So for many years, I would say after I came on board, EPC has really embraced its unique stature as an American company providing custom solutions, where now a big part of our business is working with the contractors on the elevator maintenance and the modernization side, keeping them running. I want to say 25, 30 years ago, most of our competitors were similar companies in the United States. And that has changed dramatically. Most of our competition is very large companies. They're going to sell you a product and say, you better like it, you better make it fit. We're not going to change it for you. And that has changed, and that's allowed us to really flourish on that maintenance and modernization side.
Nice. Yeah. Because of course you've got the OEMs, and then you've got a huge amount of independents out there that are doing a ton of maintenance, a ton of modernization. So I would imagine that's a good market for you guys. A few other questions that jump out. I noticed in one of the slides there was like an acronym of CPR. What was that? What is that about? Can you explain that?
So that's a really good one to bring up because it's great. It depends what company you're talking to and even what industry you're in, and what part of the world you're in. For Encoder products, there's 2 acronyms you're going to hear a lot: CPR and PPR. And they translate to counts per revolution and pulses per revolution. Now, I don't want to get too much in the weeds here, but you can take an incremental encoder signal, those ticks.
Yeah.
You can actually count the rising and falling edges of the ticks and multiply your signal. So I can buy an encoder that has 1,000 tick marks and actually make it 4,000 counts, multiply the counts on my receiving end electronics. So you'll see some manufacturers use both acronyms. One of them is referring to the lines on the disk, which is how many pulses you get out of the encoder. And the other one is referring to how many total counts you have. Very often PPR refers to the pulses coming out, and CPR refers to the actual counts you end up with in your control. At EPC, we use CPR for the counts coming out of the encoder. So if you buy 1,000 CPR encoder from Encoder Products, you're going to have 1,000 full wave pulses come out of the encoder.
Gotcha. Okay. Yeah, that's helpful. All right. Another question here. What are the standard lead times from EPC within the U.S.?
So within the U.S., I've just bragged so much about how we are vertically integrated. We don't stock almost anything on the shelf except some pre-builds of our programmables because we don't need to. Everything is built to order. So you're never going to have to ask as well, since I need this, is it on the shelf? And everything right now is built to order pretty much in 5 to 7 days. We also offer an expediting service. Depending on the product line, it's same day, 24 or 48-hour expedites, and that's based on the type of cure time of some of the components in there. But many of our products for down elevators, we can build to order same day or next day.
All right, very good. So what do you offer for, mechanical mounting? And can you match? I mean, obviously, I'm sure there's got to be, kind of a universal type mounting situation to make these things work with so many different elevators out there. How do you guys deal with that type of situation?
If you look at, I'm going to speed back here. It depends on the type of encoder you have. This one on the right here, I am sure a lot of people on this call have seen. Some shafted encoders from back in the day were very universal. 2.5-inch square mount, this is called. You see it everywhere, and we're going to match it. More than likely, you'll see it on the machine and go, EPC has a drop-in. But there's other sizes, 2-inch encoders, many hollow bore encoders. There just was no industry standard. Every manufacturer offered their own flavor. So we have multiple options in our data sheets. And we have many more options that aren't published to match specs that we have done. We have a lot of different mounting plates that we've designed to actually take our through bore encoder here and put a round plate with multiple bowl holes on it to fit various main drive motors in elevators. If it's something we haven't done before, that's when it goes to our custom engineering. We come up with a drawing and tell the customer, hey, this is what it would take, and we'd be able to match that. Basically, mechanically, there's very little we can't match.
Yeah, I would follow up since being the technical applications manager, those mechanical integrations, we've done so many of them that oftentimes we'll have already a similar solution. So modifying it for a particular customer becomes very straightforward, just because we've done so many at this point that we have many starting points that we can look at for a customer. And on the electrical side, oftentimes it's the connector, and custom connectorization is also pretty straightforward for us, as we've encountered many over the 55 years that EPC's been around.
Okay, very good, very good. I'm just curious, what is the lifespan of an encoder? Is there a timetable or what?
There is. If you go to many of our data sheets and you compare us to our competitors, for example, I encourage anybody to look at that when you're looking at which product to buy next. The main failure point of any encoder you're going to see in the elevator industry is going to be the bearings. The vast majority in this industry of encoders have a set of bearings, and that set of bearings holds a disc concentric and true to the sensor that's reading the disk. It's the only wearable component on the encoder. So other than a very very rare electrical failure, it's going to be the bearings that go. So you want to read the data sheet and look at the estimated bearing life on the data sheet. Most of our data sheets are going to say times 10 to the 9, 9 zeros for revolutions of that bearing, and that's because we use high quality bearings, name brand high quality bearings. If you compare our data sheets to things you may find online that are of lower quality, you're going to see a lot of times 7 and times 8. And that means that bearing, at times 7, that's 100 times less total revolutions that encoder is going to operate before those bearings are expected to fail. Many of our encoders bearings are highly rated for loading, especially if you have a shafted encoder that we had a picture of. I'll go back to that again. If you look at our shafted encoder here, you'll see this encoder sometimes side loaded, either with a chain and a cog or a pulley and a belt, and that's putting side load. You want to look at what the total radial load of that encoder is. This encoder here, for example, is rated for 80 pounds. You can throw an 80-pound bag of flour on the side of that shaft, and it's rated to operate. At half of that, at 40 pounds, this encoder can run at 6,000 RPM for 20 years, 24/7, at half its rated load. So that is an important thing to look at a data sheet for the lifespan of the encoder, is the mechanics of the bearings.
All right, Jared, thank you. One more question, and we'll start to wrap this up. You mentioned resolution when you were talking. Talk a little bit more about that. Help everybody on here to understand the importance of the resolution of the encoder.
Sure. We got a picture of a disk here. So an incremental disk, it ticks. We say it goes tick, 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 tick. Think of like a playing card in the spoke of a bike tire. Here's your bike tire. You throw a playing card in there, and every time a spoke goes by, the card makes a noise. My kids love to do that. And so the resolution is the number of spokes on the tire, which will equate to the number of ticks or pulses, because we're making electrical pulses here, that you make in a revolution. If I put 1,000 lines on this disk, meaning 1,000 CPR, I should expect to see 1,000 pulses exactly per revolution of that. So if my control sees 500 pulses, I can say my motor just did half a revolution. If I see 10,000 pulses, I can say my motor has rotated 10 times. And that's the purpose of resolution. Now, using it that way, that example is positioning. So that's how you can use an incremental encoder to position. Most of, from what I've experienced anyway in elevators, they use the encoder for speed control. And it's very similar. You're just dividing by time. My control has a set sampling rate, whether it be 2 milliseconds, 20 milliseconds, whatever it is, where over a uniform amount of time, it's sampling the number of pulses that it sees, and then it divides by time. And when I know how many pulses are on their disk, I can equate that to a speed that I'm running. If I'm seeing 5 pulses a second and I know how many pulses are on the disk, I can figure out the RPM of that motor. That's the other way that they're used. So the resolution, when you're in a data sheet choosing resolution, you're choosing the lines on the disk.
Very good. Very good. Okay, I think that's gonna wrap it up for us. I don't know if there's anything else you and Jared you and Sarah want to contribute. Any other points you want to make before we wrap it up?
Just one more note about contacting anyone at EPC. You can even call into our tech services. Unlike a lot of companies, you'll actually speak to a human, usually in less than a minute. And that's another way that we differentiate ourselves, is that you can actually speak to somebody with any questions you have about our products or your application.
It's always good to talk to a real person and not be stuck in that cycle of pushing buttons and trying to find somebody. So.
Yes, it is. And we have 3 people located on the East Coast, including an inside person on the East Coast for handling any kind of logistics, inquiry, shipping, what have you. So you're not waiting until 10 a.m. Eastern when our factory opens.
Nice. Yeah. It's a big market for the elevator sector for sure. Well, good deal. Guys, this was really great. Really enjoyed it. Thank you, Sarah and Jared, for really an excellent presentation. Very informative. If you didn't understand encoders and you joined this webinar, you're going to understand them a lot better now. Again, this will be sent to all that participated and all that registered and weren't able to attend. Also, this will be posted on Elevator World's website under our media tab within a few days. And just like to personally thank everybody for attending today's webinar. Jared, Sarah, thanks a lot. Really appreciate it. And you guys have a great day.
Thank you very much,
you.
T. Bruce Scott, and thank you everybody for attending.
All right. Y'all take care.